we're live.
I know. Welcome to Getting into Vault part 9. Yeah, part 9. Whew. We had to count. Yeah, counting's hard. Well, because we had a week off last week. And you went to KubeCon.
Yes.
Hopefully that was
very exciting.
Yeah, it was exciting. And now, we're back to it. Welcome to Getting into Vault. This is us doing Vault the somewhat challenging way. Doing everything from scratch. So we try not to automate anything. It's not perfect. So you'll see us make mistakes. You'll see us typing wrong commands. You'll see us looking up docs desperately and search engines and then trying to debug what went horribly wrong. So this is intended to be the imperfect way to learn Vault. So far we've progressed through the series. If you are interested in reviewing the previous episodes of the series, we do have a playlist on YouTube. You can find the entire series on hashi.co/gettingintovault. With that, we would love for you to interact with us in chat. This is interactive. Sometimes we will solicit chat for questions, opinions, help, direction, chaos, chaotic things that we should do. And so as you do interact with us in chat, be welcoming, respectful, and professional. We have our community guidelines down below. Melissa, would you like to introduce yourself and what we've been doing on this series?
Yes, I'm Melissa Green, and I am the Senior Director of Community Development here at HashiCorp. I've been in the industry now more than 20 years, which is crazy. Started out highly technical and hands-on and doing all kinds of implementations in traditional data centers. And now I am leading technical teams and building communities. So not a lot of hands-on. So I thought it would be fun to try to learn Vault and get my hands, dirty and try to figure it out. So thankfully, Rosemary is humoring me, and we are just running through it and seeing how much I can learn.
Yeah.
With the eventual goal of maybe even getting certified. So.
Oh, okay. Yeah.
As far as what we've been into, we've done a whole bunch of stuff from the initial install to setting up HA and trying to figure out different secrets engines and setting those up. Last week we did certificate and PKI. Last stream, not last week. But and now we're gonna hopefully do transit secrets, which should be exciting.
Very exciting. I think that we didn't get a chance to do transit last week. Last week we did, or not last week, last stream.
Yes.
Last stream in part 8, we did the PKI secrets engine, which issues certificates. And so that ended up taking the entire stream because we went from using Vault to issue the root CA to bringing our own offline root CA and issuing intermediate CAs from that. So we had quite a bit going on in the last stream, and we didn't get to transit secrets engine. So today we're going to talk about two sort of last things that we're going to, in terms of the Vault space, the two last bits that we're talking about our transit secrets engine and audit logging, because of course we've talked about centralizing secrets, but we never actually talked about the other part of this is just the benefit and being able to track how those secrets are being accessed. So we're going to talk about audit logs today, and then in the next 2 streams we're going to take a trip into the enterprise features. So performance replication, we're going to talk about HashiCorp Cloud Platform Vault. Folks can take a look at that, as well as HashiCorp Vault Secrets. So there are many variants of Vault depending on how you plan on using it. So we're going to talk about those. And then hopefully we'll have a Nomad stream. We do have some folks who really wanted a Nomad stream. So we might set up a Nomad stream. I'm working on that right now. Okay, so let's get started. Melissa, let's pull up Boundary, and we'll talk about Transit Secrets Engine first. So we briefly mentioned this in the last episode, but we'll recap. Transit Secrets Engine is effectively encryption in transit, or encryption in transit as a service. That's probably a lot. That's a mouthful right there. But encryption in transit is a service. Sometimes you have this. Sometimes you have, personal and identifying information in your organization. That is very typical, especially your applications need to pass these things back and forth, right? Sometimes you need to process this data, and there's not a, in terms of protecting that data, there are many layers of things that you can do. And one of the options is to say, okay, I'll encrypt that data. And when I'm processing it or after I finish processing it, and then I put it into my database somewhere, so that if someone goes into the database, they're not going to see the plain text information. They'll see the encrypted data or the ciphertext, right? So you don't necessarily have to do this. It is if you really need to do this from a data protection standpoint. And so there is a secrets engine called the Transit Secrets Engine, and the Transit Secrets Engine gives you encryption keys. That's basically what it's doing. You can use Transit Secrets Engine itself to do auto unseal. So if we refer back to my cheat sheet of what we talked about auto unseal in part 3, and we were using KMS. We had a bunch of keys to help us auto unseal Vault and decrypt Vault. You can also use the Transit Secrets Engine in another Vault cluster to unseal another Vault cluster if you want. Really, Transit Secrets Engine is there to provide an encryption key and help you encrypt and decrypt any kind of data that you have. So the Secrets Engine itself, you may or may not use it. You may or may not decide that it's something that fits your use case, but it is very powerful. And the one thing that I will say with the Transit Secrets Engine is that as we go through the steps, you'll notice that it's encrypt and decrypt, right? So it's not going to be using Vault Agent. Vault Agent won't necessarily help you do the encryption, decryption. That is a sequence you will have to do yourself. And we're going to do that manually. If you're doing it in your application, you'll have to use a Vault SDK or some kind of code that you've written to do the encryption, decryption sequence, right? So that's one thing that you have to know. Any questions or thoughts on this, Melissa?
No, I'm excited to get started.
Yeah. Any use cases or any in the past, did you ever think to yourself, I should have encrypted this data in the database or in somewhere? Or
there was definitely a database that had credit card information in it that probably should have been encrypted at some point way, way, way back.
Yeah.
And by probably, I mean definitely.
Yeah.
So
yeah.
yes.
Yeah. So and the nice benefit of this is that Transit Secrets Engine an encryption key is a secret, so you can rotate the encryption key, and once that encryption key is invalid, right, then it's very hard for someone to decrypt that data. You can always re-encrypt it with a different key using Vault, and then your data is not compromised, right? So the idea behind all of this is that there's a powerful set of consequences to using Transit Secrets Engine that might work in your benefit. And so we're just going to go through sort of the manual steps of Transit Secrets Engine. I won't really show the application side because the application side is going to be heavily dependent on your framework. So if you're doing Java, you're doing .NET, you're doing any of the other ones, they will be a little bit different in how you approach it. So, but I will put an example in the links. Okay, so let's log in. We should be in Boundary, which has our Vault server. And then if you source opt vault.env, okay. So if you do Vault secrets list, of course, we have nothing in there. That would make sense. Because we have it. This is, again, every live stream, I create a new Vault server with a new key and new token and new everything. So if we accidentally show credentials on screen, I'm sorry, no one can use this Vault cluster after the next 2 hours. So in this situation, it's completely new. We don't have anything enabled. So what we're going to do is we are going to enable the Transit Secrets Engine. So Melissa, now that you know the transit, you've enabled a lot of secrets engines. So how do we enable a secrets engine?
I think it's Vault Secrets Enable.
Yep. Mm-hmm.
And then Transit?
Yep, Transit.
Look at that.
Yeah.
So
okay.
excited.
Admittedly, this warning thing we should probably fix and just set the vault address, but it's fine. It's fine. I don't know. We could just ignore the warning for now.
What's the worst that could happen?
I know. I mean, I guess I could just export vault_ADDR, do the HTTPS thing, and just get rid of the warning. But just so everybody in the stream is like, no, why do you have this warning? And so equals, and then the HTTPS, whatever.
Quotes? Yeah.
No, you don't need to do quotes. Yeah.
Okay.
It's that HTTPS 12700, whatever.
Typing is hard.
Yeah, it's hard to come back to on a stream after this, you know. Okay, all right. So we should have the secrets of the transit secrets engine enabled.
Yes.
Okay.
Look, there it is. It's very pretty.
Excellent. Okay, it is there. Okay, so now that we've enabled the transit secrets engine, we're going to create an encryption key ring. So these are, I guess if you're using any kind of cloud KMS, you'll probably encounter the same constructs, right? So we'll create a key ring, and the key ring has the set of keys, right? So we're going to do vault right, transit /keys. And then you can name whatever your key is. You can name it. We don't have anybody on the stream with us today.
We're going to pick on Bruno.
All right, Bruno.
New guy.
Yeah, Bruno. I don't know, Bruno, if you're on the stream. Hi.
He's it's Easter Friday in Europe,
yes,
so
right. Yes.
they are off today.
Yes, happy Easter Friday. Okay, so transit secrets engine. All right, let's write. We might need. We'll see. Click enter. Yep, then enter. Oh, we have to do force. So do force. I guess if we supply data. Oh, before that.
Oh, yeah. Okay. So here.
Mm-hmm.
Look at that.
Yeah.
What else we got in here?
There we are.
Okay. Map, latest version.
Yeah. Yeah. So allow plain text backup. I guess this is a plain text backup if we decide to allow it of the key. Exportable false, imported key, it's false. You can import your own key. You can export it. There are a lot of functions here that you can include, right? So, and turn on and turn off. So we have decryption, we have encryption. Those things we do want. We are going to encrypt and decrypt. And you can also change the type as well if you would like. It also tells you how many keys there are. So you'll see there's map of one key right there. That's that. We're not going to do too much. There's auto rotate period as well. I mean, there's a lot of stuff that you can do because these are encryption. This is an encryption key. It is a secret, and you can apply any kind of the vault constructs that you want to this encryption key. Most of them are going to be pretty similar. There's just some additional values as well. Okay. So now what we're going to do is we are going to encrypt some plain text. So if you're in an application, and let's say we had a credit card number, we would want to pass it to this vault endpoint, which is transit /encrypt / the key name. We want to call the transit /encrypt / key name with the plain text payload in order to encrypt it. Vault does not store any of this, right? Vault is just doing the encryption for you. So we're going to do vault right transit /encrypt / Bruno, because I think that's our key name. Mm-hmm. And then space plain text equals. And you can, you can type something in. It does have to be base 64 encoded though. It's partially because it's partially so that it assures that you're taking out any new lines. You're not just going to like pass in. If let's say this plain text was a payload with an address and that address had new lines in it, then this wouldn't go so well if it just gets passed directly. So base 64 encoding ensures that it is preserving the value properly. So if you do go back to the equal sign with the plain text,
mm-hmm.
and then you $, parenthesis. Yeah, parenthesis.
Yeah, there we go.
Yeah. Base 64. Well, I hope it is installed. Space. And then you're going to do the the arrow, but the left pointing arrow. With that thing 3 times. Space. Yep. And then at the end of all of that, you're going to put a parenthesis. Yeah.
Boom.
There you go. Okay. So hopefully this should encrypt that. So if you hit enter. Okay. So you'll notice, yes, you'll notice there is indeed the encrypted ciphertext. So we'll need to save the ciphertext.
Where did you go? There we are. All the stuff from before. But
yeah, we can go away. We should just delete that, to be honest.
Yeah, it's fine.
Yeah. Okay. So a couple important things about the ciphertext. This is the encrypted credit card, that example that you put there.
Yeah.
Vault, it indicates it's vault. V1 is it's the version. So we use the first key version, the V1 version of this key to encrypt it. This is important, especially if you decide to rotate the encryption key. You need to know what the ciphertext, which version of the ciphertext which version of the key Vault should use to decrypt the ciphertext. There we go. Wow, lots of words. Okay, so what we're going to do then is we are going to, we've got the ciphertext now, so let's decrypt it, right, just to show that it actually works. So if you're an application and your application needs to decrypt it, you're going to do write, actually. They're both write.
Right, okay.
Yeah. So vault write, transit/decrypt.
Oh, I see.
Decrypt/Bruno equal space ciphertext. Ciphertext equals, and then you're going to get that Vault V1 thingy.
Oh, the whole thing.
The whole thing. Yeah, because the prefix is important because it tells Vault which keys it should be using in order to decrypt it. So if you put not parentheses, quotes here, hopefully it will preserve it. Actually, I don't think you need it. It should be fine. Let's see.
What's the worst that could happen?
Yeah, what's the worst that could happen? There we go.
Oh.
Well, it is base64 encoded, so if you copy that value.
Oh, okay.
Yeah. If you copy that plain text value there. We did base64 encode it, just again to preserve any new lines, any special characters, right? Base64 encoding ensures that we, if you do base64 space -D.
-D?
Yep, -D. And then the 3 arrows. What are those arrows called? Sorry, left arrows. You want to push, I don't even know what those are called. Space, and then put in the base64 that you have there. All right, there you go.
Look at that. It's
there we
beautiful.
are. Yeah.
It's a fake credit card number.
Exactly.
Yay.
So again, Vault doesn't store the ciphertext. It doesn't store the plain text. All it's doing is taking this information and then encrypting and decrypting it for you using the encryption key that it has in that transit secrets engine. And so when you're using an application, this means that you do have to write this code, right? You do have to write some code to call the encryption endpoint for Vault and call the decryption endpoint for Vault if you want to manipulate the data. It's not something that you can use Vault Agent for example. It is something you have to write in your code to do this sequence. It's an API call. If you're looking at the CLI, right now, Melissa, you're using the CLI, so it's not quite obvious, but it is an HTTP endpoint in transit encrypt, and then the key name, and transit decrypt the key name, and you pass in the plain text and the ciphertext. And so according to all this, of course, if you look at the previous parts, it means that you have to have the correct policy on the application to do this. You have to have the right access control and tokens and a token granted to the application in order to have permissions to access the transit encrypt and transit decrypt endpoints. So that's encrypting and decrypting. Let's rotate the key. We'll give it a rotation a shot. And see how that goes. So what we're going to do is going to do Vault write -F, and then we're going to do transit/keys/Bruno/rotate. Oh, sorry, no slash on the beginning of the transit. Yeah, rotate. So what this will do is give us a version 2 of our encryption key. So if you go for that, there is now a latest version 2. Yeah. So important thing to know is that let's decrypt the ciphertext from version 1 again, because again, we have a version 2. So let's go back and decrypt that, right? So if you hit enter, it will still decrypt it for you. And that's because it has that prefix vault v1. Now let's rewrap. Let's re-encrypt this, right? Because it is using the second version. It is using the first version. We have a second version of the key. So what we're going to do is we're going to do an operation called rewrap. Or actually, no, sorry, not rewrap. Yeah, we're just going to re-encrypt. Sorry, we're just going to re-encrypt, and that way we have the two. So, let me double check I have the correct sequence. Actually, no. We don't have to re-encrypt. It's fine. Okay, so we're going to do a process called rewrap. And what rewrap is going to do is it's going to re-encrypt the payload with the new version. So we have a version 1, and let's say now we have a version 2. So we're going to do vault right translate / rewrap / Bruno.
Rewrap.
Yeah. / Bruno. And then ciphertext. And then you're going to copy the version 1 of the ciphertext, right? So why is this operation important? Well, imagine you have all this data in your database. You know, you have a database and it has the vault v1, the encrypted, the ciphertext here. And you don't know what that decrypted payload is, right? You, as an operator, maybe you don't need to know. You just know that it's encrypted by the transit secrets engine. So you need to re-encrypt all of the data in this database to use the new encryption key. And that's why you can use the rewrap operation. This means that if, Melissa, you do vault right transit decrypt Bruno with the ciphertext, the version 2 of the ciphertext.
Okay.
Yeah. So if you decrypt and you're going to use the version 2 of the ciphertext.
Yep.
There we go. And you'll notice it's the same plain text. And if you base 64 decode, it is going to be the same. It's going to be the same thing. Yeah. So basically what this means is that if you are a developer and you do need to decrypt these payloads for processing, you have access to the decrypt endpoint and you can decrypt whatever ciphertext you might get out of your database or wherever it's coming from, right? But as an operator, maybe you don't have access. You don't have the access to the PII. You don't need access to the PII, right? That's encrypted by Vault. You just want to rotate everything to make sure it's using the latest encryption key. So in this case, you would use the rewrap operation to re-encrypt all of that data without you knowing what that data is. So you don't have to do the process of decrypting and then re-encrypting. Instead, Vault will handle rewrapping the payload into the next version of the encryption key. So that is that. That's it. I mean, that was 26 minutes or so of it.
Okay, so when you're actually doing this programmatically, I assume you're storing the keys in the database, or not the keys, the ciphertext in the database, and you're able to programmatically like switch.
Yeah. So the thing is that, if you are storing it in the database, and it's maybe got multiple versions of these encryption keys, you can tell you just need that prefix, right? So Vault automatically will know once you pass the API call with the prefix, it will know which version of the encryption key you use. Now, if you delete one of the versions of the encryption keys for some reason or another, then it will become more of an issue. But if it is just if you have created a new encryption key and you need to revoke the old one, you, an operator, need to go into the database and then rewrap everything in order for the application to know what's going on. If that encryption key doesn't exist anymore, then the application will only do what it is able to do, which is call the decrypt endpoint with the ciphertext that it has available from the database. So you do need to go into the database and make sure that you're updating it yourself. If you do rotate and you do revoke the previous version of the key. Okay, let me actually show what this looks like though in code, because I think it might be a little bit easier. Unfortunately, how does this increase? Okay, here we go. So I have an example app. It's nothing like it's not complicated, but okay, let's see if this will work. Okay, it's IntelliJ, so it might be a little small. Let me just increase the size. Unfortunately, I don't think I can increase the size bigger. View. No, apparently that is as big as it goes. Okay, so there's a couple of important things that when you, and if you're doing this, this is using Spring Boot. So there are a lot of things built in that you might not see in other frameworks, right? But if you're using something like Spring Boot, what you'll effectively need to do is I recommend creating a separate class that handles the vault operation of encrypting, decrypting. So here I'm encrypting the billing address and I'm decrypting the billing address. And I'm using the Vault Core Spring Framework, or the Vault Spring Framework, Spring Boot Vault Framework. And what it will do is there's an operation for transit, and it will allow the decrypt and encrypt. For the most part, there's not much to it. There's just the key, and then it tells you, okay, then the billing address, and that encrypt the payload. So when you are using an SDK or a library like this, it's not an additional issue. You do need to create a class that has the function of encrypt decrypt that calls the vault endpoint, encrypt decrypt endpoint. It is pretty neat though. In Spring, there is an attribute converter that you can write. And so what you'll do is you'll create some kind of converter that takes the ciphertext of the column or the plain text and then puts it into and converts it into the ciphertext. So here, this is effectively what I'm doing. There's the encrypt, right, where it will just say, okay, I'm going to convert the database column. And then if I want to retrieve information out of the column, then I'm going to decrypt it with Vault. So this is a way for me to check that prefix and then make sure if it is starting with the Vault prefix, I know that column, that database column, is encrypted with the transit secrets engine. So I'm just going to decrypt it, right? So that's sort of like the short, very, very short knowledge of what you need in order to do this within an application itself. Now, once it's being stored, I have to find where I put this in here. It is somewhere in here. I can promise it's somewhere in here. It's been a while. Okay, here we go. And so this is where, again, Spring Boot has these lovely annotations and is able to do this. But when you store it into the database, you're going to convert the plain text into a ciphertext and then store it into the database. So that's effectively what this is doing. It is using an SDK, so you do have to have a token that allows you to authenticate to Vault and use the transit encrypt, transit decrypt endpoints. But from an application perspective, that's all you probably need to really do, unless you're doing some more complicated stuff, and you potentially are going to be having multiple versions of encryption keys within the ciphertext, right? But that's a little bit different. It should be mostly handled though once you make an API call to Vault. So that's where this is. That's that. Okay. All right. We are partially through that. Now, Melissa, we are going to go to audit logs. Do you have any other questions on transit? Any thoughts, concerns? You're on mute.
I do not, but if we have questions from the audience, I'm happy to see what we got. So far, it's been a little quiet this morning.
Yeah, it's a little quieter this morning. Okay. So we've got that. Let's cover audit logging, because what is an operation? What's the point of operating? Well, if you can't audit what people are doing to those secrets.
Yes.
So this one's going to be interesting. We're going to turn on audit logging. And there's a concept called audit devices. I will pop the audit devices. Put the there we go. Aha. Okay. So audit devices. Audit devices are basically where you're going to put all of the audit logs. There's a number of places that you can put it. I think there's like Splunk, there's Datadog, there's a lot of them. And we are going to be using file-based because some of the other ones do require some additional enterprise licensing and things like that. So we're just going to show the file-based one just so folks have a sense of what it looks like. And that way we don't have to add anything new to it. You can also enable the audit logs using the config. We're not going to do that because we already have a live running vault. I mean, we could restart it, but there is an audit device setup that you can put in I think config startup or something. But we're just going to enable the audit right now. So we're going to go back to the command line. Melissa, if you could go back to Boundary.
Yep. There we are.
Okay. I see a screen. It's a big pinwheel.
Oh no.
Oh no. Boundary?
Boundary?
It's not. I don't see Boundary on the screen.
Yeah, I think it's probably an internet issue or a StreamYard issue.
No.
So let's give it some grace. If needed, I can stop sharing and reshare again.
Yeah, you might have to.
Okay, let's see here. All the hall. How about now?
Nope. I get a pinwheel.
All right, let's take it off of stream real quick, and then I'll re-log in to Boundary and see if that helps.
Okay. Well, I'm gonna take it off stream, and while you mute and go to Boundary and see what's going on.
Okay.
I'm going to sit here for a second and entertain the crowd. I don't know. How's everyone doing today?
It should be noted too that if you have questions on LinkedIn, we won't always see them.
Yeah.
But we will answer them either during or after the stream. So
yes, that is true. I don't see any comments on LinkedIn right now. I think we're just it's a quieter day. I think we're all a little bit much. It's a bit much. Is there anything else anybody else wants to see on these vault streams? Because we're going to end. I think this is our. Then we have 2 more after this one, so we are going to conclude the series after this. It's not intended to be like a deep introduction per se, as much as just like a broader and then more painstaking introduction to it. So if there is something you do want to see, another secrets engine, something else, do let us know. In terms of what we went through before, we had, let me double check. We went through cluster seal, and then storage backends, high availability, and server auto join, auto unsealing, re-keying, and policies, cluster backups and authentication, policies, and the AWS auth method. So we did do that. Dynamic secrets and leases. We ended up doing the database secrets engine there. Kubernetes, certificates, which is PKI. And so now we're at transit secrets and auto logs. So if there's anything you do want to see, anything else you want to see on the stream or you want to learn about, let us know. We will try to find an expert if I'm not the expert or we don't have someone who knows it. So we will find someone. But in the meantime.
Is it working?
I don't know. I just see the big pinwheel again.
Oh no. So on my screen, I see it.
Okay.
and everything's fine, but I'm not watching the stream either.
Okay.
Do you see the credit card stuff, or is it just?
I just see your, I just see a pinwheel and, okay, hold on. All right, who sees a pinwheel on the screen and who sees like it's like basically, I see StreamYard right now.
Yeah, I have a feeling it's a StreamYard screen sharing issue then. Either that or it's something specific to my desktop.
Okay.
So we could try sharing your screen.
Yeah, we can do it on mine. Why not? There we go. There's Boundary.
Hold on, let me see if I see Boundary on your screen. Yes, I see Boundary on your screen. So
okay,
let's
do that. Dun dun dun.
Dun dun dun.
Technical difficulties. Okay, we're gonna do this then. Let me pull up Boundary, and we're gonna connect through. Let me do that. Okay. All right. This is why we have Boundary, folks. It makes it easier for everybody to connect into the same thing at the same time. Okay.
You got to do our source again.
Yeah. Okay. So, all right. We're going to do audit logging. I stand corrected. I don't know. I can't remember. I'm mixing it up with console. Console will allow you to turn on audit logging in file. Like if you in startup, you can configure a file to do so. I honestly can't remember if Vault will allow you to do it. I think you actually have to do a Vault audit enable. So Vault audit is basically the command that you're going to look at. So Vault audit list. You'll notice there's nothing happening, right? We do not have audit logging set up, which means that we don't have it enabled. I believe Michael, who, if you haven't checked out our Kubernetes stream, Michael does have audit log, an audit log example online. So I'm going to put audit log example, and it goes to Elasticsearch. So if folks are interested in that, you can go ahead and take a look. But that one has some more details on if you were to put it somewhere else that isn't a file. But we're just going to do file today because everything else requires either a license or something else. So what we're going to do is we're going to do Vault audit enable path. What path would you like, Melissa? It could be any path. Yeah, because you can have multiple audit. You can have multiple files, right? You can have multiple paths. So we're just, you could have a file path, and then you can have one that goes to,
So we could do like log. User local log.
Well, the name, we could just name it whatever. This is like the Vault path, so we can name it Melissa.
That's
or
fine.
Bruno. Bruno again. We'll just name it Bruno again.
Okay.
Okay. And then file path equals what file path do you think?
Can we use dev standard out for Kubernetes installation? This is the question. So can we?
That's a good question. I suppose I guess you could. I never actually tried it. We should give it a try. Basically, it's like you would funnel the audit logs to standard out, right? So instead of the Vault logs, if you do start up the Vault logs, if you're on a Vault server on Kubernetes and you start up the Vault logs, maybe we'll test this out after we do a file path that's not dev standard out, because I'm worried if I do dev standard out, it will kind of break it. So
that's fine. Let's try it, and then we can go back to Sam's suggestion for our little chaos experiment.
Yeah.
Thank you,
okay. Opt Vault
log, maybe.
Log. Yeah, that should work, right?
Kind of boring, but
yeah. You know what? We'll do audit.log because why not? Here we are. Yeah, so it is possible to do multiple file paths. So we'll try a different file path. But we should see Bruno is a file path. Yay. Oh yes, and you can enable logs on standard out. This is useful when running in a container. There is actually a note. So yes, Sam, we can actually do that. This is the file audit device. You'll want to set up a file audit device, which is what we're doing now. Only ours is going to be going to a file. We can try standard out in a bit. We'll check that out, but it will be useful when running in a container. So that is it. That is possible. Okay, so we should now have a opt vault. What we should have is an audit.log file. So I'm just going to audit.log. Not much is happening, if you can imagine, mostly because we haven't actually done anything to it. It's a bit hard to read because there's quite a few different requests going on. But you'll notice there's, in general, the payload is going to have quite a bit of information. This is about us going onto the sys audit path. So this is us turning on and getting information from the audit path. So this is the command we effectively just had. Let me see if I can do this. Yeah. If I don't even remember this, I don't even know if we have JQ. Oh, here we go. That's a lot better. Okay, so some of the paths that you'll need to know, for example, is, okay, what is the identity that authenticated to the endpoint? So this identity is root. So we are using the root token and getting to the, this is the request coming from that root token. And then you'll see the request. So the request includes the mount class, which is a secret, sys, system, namespaces for, if you're on enterprise, you have namespacing. What is the operation, which is read. The path is sys audit. So this was us reading from that audit path. And then we also get information that here is the audit list. This is the list of audit endpoint of audit devices that we have enabled, right? So this is effectively what this is telling us. So Melissa, you had transit, right? So let me do a decryption, a decryption call, right, with the payload. So what we should see is something similar, right? What you'll see is that I have, using the root password or the root token, and I have accessed the transit secrets engine, and it is an update operation. I've decrypted using the Bruno key, and this is my plain text, or the plain text, the HMAC of the plain text. It doesn't actually give me the plain text specifically, but the HMAC of the plain text, as well as some of the information on what the response lineup looks like. So in terms of audit, any API call that you're making to Vault will have a response based on, with all of this information on who authenticated, who was retrieving that information, what's the response and request that someone passed in. Notice it doesn't actually have the ciphertext, it just has the HMAC of it. It doesn't have the ciphertext itself. So if someone does get into the audit logs, they're not going to immediately be able to extract the payloads that you pass through. Any questions, Melissa? I mean, I guess, is there anything we want to see?
Okay, so I don't know how much of this we can simulate, but when you're troubleshooting, what are you looking for when, say, you're concerned about someone getting a hold of your secrets that shouldn't have them?
Yeah, it's a good question. I mean, we could probably, part of this is also like it might also be policy, right? Because let's go through this process of saying, I'm trying to think if there's a way that we can simulate a policy, like the policy, right?
Well, I mean, we shouldn't be using the root token in an ideal world, right?
No, we should not be. So we'll go back and create tokens again. If you can guide me through how we create tokens.
Maybe.
Okay. All right. So let's go back and let's create tokens again. Okay. So step one, we have a token. And then we're going to create a new token, right? So let's do vault token create. TTL. I'll do 1 hour. Use limit is, I don't want to put a use limit on it. we should actually create a vault policy first, right?
Yes.
So policy.hcl. Let's create the policy that allows us to encrypt and decrypt stuff from Transit Secrets Engine, because that's the one we have enabled. So it's probably easier just to do that. So let me pull that up, and let me pull my mic closer so that folks can actually hear me, because I'm turned slightly the other direction. Okay, so let me pull this up. I'm sorry, everybody. We got to create tokens. We got to create the policy. So I'm just going to go in here. All right, so let me just give an example of Bruno. I'm going to do Bruno here. Bruno, update, Bruno. Okay, so that should be our policy. We'll do vault policy write, policy.hcl. Oh, let's call this transit Bruno. No. Okay, we're going to help. Typing is hard today. Okay, so vault policy write Bruno. Policy.hcl. So what this will do is create a policy that allows us to read encrypt and decrypt the Bruno, anything with the Bruno encryption key, right? So that is going to allow any token that we create. So I'll do a vault token create policy Bruno, and then TTL 2 hours. Okay, so I'm going to save this token. Let me just pull up something so that I can save it. Remember, this is the token. The token has default and Bruno. So that means that it has the ability, you have the ability for it to renew itself and all, but you can only access the Bruno key. So if I use this vault token, and then vault decrypt. Okay, so I'm going to decrypt this plain text that we had before, right? But I'm going to use this token, which we had specified. So I'm going to use the token, not the root token, but this token that we've specifically locked down just to decrypt Bruno's the key using Bruno's encryption key. So when I check that out, you're going to see that the token, it is a token. It has the policy Bruno on default. And then you'll see that it is going to have the granting policy of Bruno, token policy Bruno. So all of these things indicate that the request was successful, right? That it did indeed retrieve the information. The response was like, okay, this is great. Now, what if we use Bruno to access another secret? So if I do vault secret enable KVV2, right? And then I store vault KV put path KVV2. I don't know. Passwords. Melissa equals 123. Such a secure password. Okay. So we're going to store, I'm just going to store an example secret here. Oh, no. Does this not, did I do this wrong? Oh, KV put mount. Put mount.
It's the slash, yeah.
KV put mount KVV2 and then password. Please tell me that this works now. Okay, that works. Okay, so then this is the secret path, right? So knowing that I have this vault token, what I'm going to do now is I'm just going to try to retrieve that key, right? So in terms of if I were troubleshooting where something went wrong, who's accessing what, we can just get mount equals KVV2 passwords, right? It tells me I don't have the ability to do this, right? In terms of audit logging and trying to find out what's happening, I would want to look for a couple different things, right? The first thing is that, okay, first of all, what is the auth method being used? So you'll either get token, you'll get Kubernetes auth method, AWS auth method, whatever the auth method is, it will be outlined here, as well as the policies attached to it. And so the policies are something that you can retrieve and look if the policy is too generous, right? There's too much that's allowing someone to do something, or there's too little. And then the other thing that you might check is the permission denied. Are there repeated permission denied because there's some kind of malicious actor who is attempting to retrieve the retrieve the secret but isn't able to? In that case, that's a lot easier to find. But if you were to look for whether or not someone unauthorized tried to get to a secret, the tricky part is knowing whether or not the policy is actually matching the secret path. So you may decide you're going to audit whether or not the certain policies that you have are able to relate to the secret path that you're trying to access. And that's not always as easy to check. In terms of flagging unauthorized access, you might say, I'll flag if I see someone using the root token, right? Anytime someone uses the root token, I'll flag that. Anytime I see someone who has a policy that's that I know to be global management, like for example, it's a root policy, anytime someone uses the root policy, I'm going to flag that usage as well. And those are some of the more straightforward ways to look for it. The other ways are just, we'll have to, in terms of troubleshooting, you'll have to reconstruct the API call that the application or the user is making with the policy that's available to them, as well as the secret API path. Any questions, Melissa?
Is there an easier way to do this somewhere?
I'm sure do you know of an easier way to do this?
No.
I sure wish, I mean, like in terms of audit logs, right? There's a lot of information here. I'm sure there's folks who can pipe up in chat. If you are using these audit logs and you're funneling them to a metric, some kind of log collector somewhere, it could be that you decide to index on some of these values and parse and choose, which of these values are most important. So anytime, again, if there is an error, anytime there's, some kind of access using root, right? If you know that your policies just don't ever allow root access, right? Or that you don't ever want someone to use the root token for anything, then you want to alert on that, right? So those are kind of the easier ways to do it. But unfortunately, with audit logs, there's a lot of information and you just have to parse through it. And even then, the paths themselves are a little bit tricky, right? It's not exclusively like, here is the, anytime someone does KVB2 mount, right? You have to know the exact path as well.
Right. Yeah. The manager in me just wants a report that says these policies map to these things.
Yeah, it's like you have to kind of export all your policies, and that's kind of a tricky thing. Like you can list and then export all your policies all the time, and then audit them. If you're using Vault Enterprise, you can use Sentinel to restrict certain policies or evaluate whether or not certain policies can and cannot be created. So the possibilities are there. If you're using something like Sentinel that alerts on or stops or gates certain creation of certain policies and things like that. But with the community edition of Vault that we're using here, there's not really a great way to stop it. I mean, you could use Terraform, and if you use Terraform to create all of your policies, and you don't let anybody have access, break glass access to the Vault API itself, you could theoretically use some policy as code to stop it from being created. But again, you have to be very disciplined, right, in how you manage these policies. If you are allowing people to go in and manually create the policies, that opens up quite a bit of risk from in terms of someone creating the wrong policy, versus if you do use Terraform and you do some kind of as code approach where you're only allowing certain policies and you're auditing the creation of those policies before they even get pushed into Vault. So there's a couple different ways to do it, but it depends if you decide to shift it to the left by upon policy creation, or you shift right and you do continued audit by exporting all of the policies available and then mapping them and double checking the paths that they are including. So Yeah. Yeah. I wish we had like, the policy checker that checks like, do you use this API endpoint often? Do you actually use this API endpoint often? And if no, then lock it down further. Like a lot of the cloud providers have that, where you have if you have a service account or a service principal or something, it will let you know whether or not the service account is actually using all of the permissions that you've granted to it. And if not, you can tell it to narrow it down just to the permissions that it needs. So I kind of wish we had that, but we don't have that in this edition of Vault.
Kind of like fraud detection on credit cards, huh?
Yeah.
It's like, oh, you don't normally do this with this permission. Do you still need it?
Yeah, exactly. Yeah, we don't have that here. Anyway, that's a very, very short introduction to audit logs. There are, again, far more audit logs. And to answer someone's question, Sam's question in chat, yes, you can use standard out if you want to push out audit logs in a container. There's also syslog, there's socket. So there's a lot of other places that you can enable audit logging as well.
Super cool.
I know, that was unexpectedly fast for this stream. Is there anything else we should cover that I missed? I feel like we're missing a lot of different pieces of Vault. But I think in terms of other secrets engines are there for you, but they are different. And so you will have to decide, which ones you use, and they are going to be configured differently. But there are other things that, we could consider showing, but, at least this is the here is Community Vault. Here is how you run it. There's enterprise stuff. We can talk about that later.
We will, right?
We will.
We'll talk
about that next week. Yeah, we'll talk about that next week. I don't want to add it to this week's episode though, because it feels like it's a lot of information in this one episode. So we might just end early today.
And wish everybody a happy holiday weekend.
I know, happy holiday weekend.
Observing.
Yes. Yeah, exactly. So Melissa, what did we learn today? Since we're going to wrap up, this was way faster than I thought.
So we covered encrypting secrets in transit, is what I'm going to call that, and decrypting them, and how to rotate them, or at least rewrap them.
Yeah.
And then we covered audit logging and what to look for.
Yeah, exactly. And very exciting. Again, if you want to check out more on audit logs, there's plenty more. There are a lot of audit devices, but again, it's very flexible in some ways. It will depend on what your log collector is. So if you're collecting logs and you're ingesting them somewhere, whether it be Splunk or otherwise, you will have to do all this indexing yourself. I can't say that there's specific stuff that it will all depend. I'm sure we have some recommendations there, but do check out the audit device, and that sort of gets you started with how you can audit access. With that, I think we're gonna turn off the stream for today. That was a lot faster than I thought. But next week we're going to talk about HCP and HVS. We're going to talk about performance replication. Melissa, I don't think we're going to go deep into performance replication, meaning we're not going to set it up ourselves. We're just going to use HCP Vault to do it. But we are going to talk a little bit about the nuances of performance replication, things to understand, things to consider, especially if you're doing replication across secrets engines and things like that. And then we're going to talk about HashiCorp Vault Secrets, which is just, it's an easier way to store your secrets. You don't have to know Vault. So everything that we learned about unsealing will no longer be necessary. I know, right? You just store your secrets somewhere and then that's it.
It's just magic.
Yeah, it's just magic. There you are. Magic. You can retrieve from it. And so we'll do that. But that's for the next one. With that, thank you everybody for joining us today on this shorter stream. And we hope you have a fantastic weekend. And we will hopefully have you on the next episode.
Yes, thank you all.
Mm-hmm.